Okay, this is a video of what we talked about in class, so maybe you can use this for review, and hopefully we're going to answer some questions about this video. Circular motion, what I'd like you to be able to talk about from circular motion or learn is to explain why an object moving in a circle at a constant speed is actually being accelerated, even though it's moving at a constant speed. Describe how this thing that we call centripetal acceleration depends upon object speed and the radius of the circle, and identify the force that causes centripetal acceleration in different situations. Let's say when a car is getting off an expressway, on an exit ramp that is closed, what's the force that provides the centripetal acceleration? First of all, circular motion is the movement of an object at a constant speed in a circle with a fixed radius. Okay? Some terms that you should be familiar with: centripetal acceleration. What is centripetal acceleration? We talked about that in class. Centripetal force, linear or tangential velocity. That would be the velocity that an object that maybe I'm spinning around in a circle on the end of a string. If I cut the string, the velocity that it takes off at the point that I cut it. Tangent to the circle. That's why they call it tangential velocity. Angular displacement. How far, in terms of degrees or radians, if you will, has an object that's moving in a circle gone? Okay? It can be anywhere from 0 to 360, or if you're going more than one time around, it might be, we might say 5 RPMs, 5 revolutions per minute. It's gone 5 circles. Here's some terms for circular motion, okay? Here we have the path represented by a circle. The distance around a circle, you probably remember, is 2 pi r, where r is the radius. That's called the circumference. Velocity is distance over time, and since in one time it goes to circumference, we can say the velocity equals the circumference divided by the time. Centripetal acceleration, our symbol would be AC. Sometimes that's written as A subscript C, is equal to v squared, where v is the velocity of the object divided by the radius. Okay? Centripetal force would just be, according to Newton's second law, the mass of the object times the acceleration. So it's m times the centripetal acceleration. Centripetal force, it's interesting to note, is always to the center of the circle, points to the center of the circle. Some other objects or other facts. The period, when we talk about motion that's repeated or periodic, we can talk about how long it takes to complete one cycle. In this case, a cycle is one complete circle, and that's denoted by the letter capital T. Okay? The period of an object that's undergoing centripetal motion is represented by capital T, and it's equal to 1, it's equal to 1 divided by the frequency. So then you might ask the frequency, what's the frequency? Frequency is how many cycles, okay, or how many revolutions you make in 1 second. So when we say an object is turning at 3,500 RPMs, that would be revolutions, which is a cycle, per minute. So to find the frequency, you would have to divide that by 60 seconds, okay? How do we get the formula for centripetal acceleration? Okay, so if you look here, what we've got is we have 2 vectors. We've got a vector that's going straight up at this point in time. Notice it's tangent to the circle. And then the object, which is spinning counterclockwise, we have another vector which represents the velocity, same length, because it's constant speed, at this point in time. Okay? Alright, I could form a vector triangle here if I wanted to by taking these 2 vectors. Okay, this would be the angle that they've gone. In other words, this object has moved a certain angular displacement, let's call it theta, in this period of time. And the difference between these 2 vectors would be this line here. Okay, or we could say it's VF minus VI or V2 minus V1. Okay? We can also draw another triangle here, represented by the two radiuses, okay? This would be a radius of the circle, this would be a radius of the circle. This chord is called S, or the arc length. For fairly small angles of theta, okay, this chord is actually equal to the arc length here, okay? In other words, the distance that the object went from V1 to V2. Okay, for small angular displacements, that's true. Okay, so the formula, if you remember from geometry over here, theta equals arc length over r. Okay, arc length over r. But what is the arc length equal to? Well, the arc length, if you say for small angles, it's the same as this part of the circumference, is equal to the distance the object went divided by r. The distance, the arc length, using v equals distance over t, solving that for distance, which is arc length, we get it equals v times delta t. So we come up with this formula. Okay, so theta equals v delta t over r. But theta also equals, okay, theta also equals, using similar triangles, okay, this would be similar to delta S, the proportion, and this would be R. Theta also equals delta V over V. So if theta equals delta V over V and theta equals V delta T over R, we can set these two things equal by the transitivity law, and we get delta V delta T over R equals delta V over V. Okay, and when we solve these two things, okay, when we solve these two things for delta V over delta T, we get delta V over delta T, change in velocity over time, that's acceleration, equals V squared over R. So that's where the formula for centripetal acceleration comes from. Okay? So AC equals V squared over R, where R is the radius of the circle and V is the linear velocity. If we just use Newton's second law, F equals ma, we find out that centripetal force would equal mass times V squared over R. Here's a sample problem, okay? In this sample problem, I'd like you to work out on your paper. We have a 13-gram rubber stopper. It's attached to a 0.93 millimeter string. The stopper is swinging in a horizontal circle, making one revolution in 1.8 seconds. Find the tension force exerted by the string on the stopper. Okay, the first thing that you have to do here is you have to change grams to what? To kilograms. Okay, so we change grams to kilograms, and that should be 0.013 kilograms. Then the next thing we need to do is we need to find out the velocity. Okay, I don't have the velocity, but I do know something. I know that the radius here is 0.93 meters. If I know the radius, can I find how far it goes in one revolution? Yeah, it's 2 pi r. So I would take 2 pi and multiply it by 0.93. And now I know the time, so can I figure out what the speed is? Yeah, it would be 2 pi r divided by 1.18. That would be the speed. Now I know V, I know R, and I know M. Can I find the centripetal force? And the centripetal force in this case is the tension in the string, because it's this pulling on the string that is making the object go in a circle. So after you do all this, I'm sorry for advancing that slide, after you do all this, your final answer should be, you tell me. Thank you.